Hello and welcome to part 2 of the write-up video for the SecurityValley CTF challenge Forgotten License Key. I think in part 1 of the video we have stopped right after that we have made it to this point here, right after the validate license format. So that means we have figured out what was the required checksum for the first block, the required checksum for the second block, and what was a valid key input after some brute forcing, but we have still no clue how the expected program output should look like. Yeah, so for example, this is still some gibberish here, and we need to find out how the program is working and what is the correct license key input to solve the challenge. So therefore, let's adjust here a little bit the control flow. I would say let's color some things out here and some yellow so that we have better overview of how our current flow or the current program flow is working. And let's jump here in the load static license function. And we can do here the same, cause on every go function, this is usually the stack setup, because go has another way of passing arguments to stack frames around than you may probably know. But it's so many content or so many things that needs to be explained. I really highly recommend to watching a video from the Kaspersky Tech Lab where someone is explaining you all the things about reversing Go binaries. So, but let's focus here a little bit of what the function is made doing, and we can add some comments here. So this is here load the static license, and then we need to figure out this is usually runtime that are Go calls, string to slice bytes. So if you're not knowing what this may mean, you can go here to pkg.go.dev and then you can search for symbols and packages here, and then you see, for example, the string to byte slice function, and this is what the function implies. You get a string and return a byte array representation of the string. And in Go, the arguments get passed by the stack offset, so to say, and this is what you see here. So we need to figure out what kind of string will here kind of convert to a slice. You can compare it with an array of bytes that can, if we do some assumption here, it is more or less possible that this is our input key here. Yeah, so we can try to write some pseudo code here within, so that we create the byte slice of input key, and before that we have load the static license value, and then we need to see what in between is happening here. So let's jump in and see what is maybe the return value of the function, and we have the same here. We can get this and this. Let's also color this out, and then we see here that some static things get loaded by some data offsets here. So this is usually the indicator for data. And then we have again here a string join, which comes from the Go strings package, and we have something encode that here we load something, so different data position. Then maybe the data position here gets joined to a string, and then the string is usually base 64 encoded, and here we get the decode representation of the loaded string. So we can, if you do some assumption, we can think about, for example, load free data, let's call it data objects, join that object to a string, and let's add here base 64 data object, and then the function return, let's, for example, base 64 decode, and then the free loaded data objects. But we need to verify that after we do some real debugging here. And let's update the comment here by load free base 64 data objects and return the decoded bytes. So should be enough at a comment here. And then we need to prove our assumption, so that this here is a byte representation of our input key, which we have passed as a command line argument. And then we need to follow along here a little bit. So panic divide, we can get rid of this, and also here, so that we can kindly ignore those areas. And then let's see what happened here. So this is kind of looping here. So we need to find out which values here gets iterated. And this here is interesting. Let me zoom in here a little bit. Here's usually an XOR operation. Or it's clear that here's an XOR operation. And we need to check which values here get XOR'd, and maybe our assumption can be extended to that we use the base 64 decoded bytes, and we have a byte array of the input license key, that they get processed in a loop. For example, this one here, and this one here, and that we do some XOR with this object here. Let's say with the index for sure, and with the second object, and the result is let's have here a result that's get printed out to standard out, and we need to verify that. Remember, our input here was 701J-0 capital D1U. And remember that we have some fixed position. For example, the 7 here was required from the license validation function, and we have always the output of a capital S here. So let's run a new line. So maybe we have 7 XOR something is capital S, and we can simply reverse the operation to see if we have if we can make an assumption what we would expect during the debug session. So we can, I think we can say from 7 no, this bullshit. Let me quickly let's do it with the debugger right now. So let's try to verify this one here, that this operation is working. And we need to prove all the assumption here that we have made so far. So therefore, I would say let's add a few breakpoints in the program. So first is, I would say, let's add breakpoint here and here. And in the static license, I want to have a breakpoint here. And before we convert a string to the slice of bytes, I want to also have breakpoint here. So before we start here with the green play button, the debug session, two important things. So the one thing is with the debugger setup in the edit exceptions, I had to set an exception here for the SecurityValley event, and I need to pass it to the application and don't suspend the program. So otherwise I were not able to debug properly the binary here. And I've also set for the process options, which I have not set at the moment, the key here, which is the final result after the checksum Python cracking script from part 1 as an input. And with all that prepared, we can start the debugging session and say yes here. And let's see where we end up with our first breakpoint. This is right before, let's get our notes here, that we have, our assumption was that 3 base64 data objects was loaded and then joined to a final base64 string, and that the function returned the base64 decoded result from that string here. So we should be able to see right before here from the registers, which is the way Go passes values to functions around, we should see something that looks like a base64 string. So let's look here a little bit, and we can, by clicking on those registers, we can jump into the data, and this looks really familiar to a base64 representation. So I would say let's quickly copy and paste it, then spin it up here in an editor, mark all those lines, and this could be the first verification that this assumption here was correct. And let's have notes here, so that this is the object. And then let's jump back, and then let's go to the next breakpoint, which is the string to slice bytes. And our assumption here was that the input key here will kind of convert it to a byte slice representation of the string. And let's see what we have here in the values. And yeah, so if you see, for the sake that this function receives one argument here, or one function parameter, we can verify that this function input here is our input key. So we can also say this one here is also correct. Okay, so then we need to jump our next breakpoint, which was in the loop where we've seen the XOR operation here. And we see here some values in hex representation, which is 64 and 37. And let's write it down here. So we have, let's have it here with an XOR operation with hex 64 and with hex 37. And I would say we can see what is the output. I think we can do that with Python, if I remember quick and correctly. So we can simply say hex 64 XOR which is 83. And then let's see which character we have here, which is the capital S. And this is super interesting now. So that our assumption here, what we have taken, how the program is working, is kind of correct. So if we recap this a little bit, and keep in mind this is just a quick write-up, yeah, and I have spent a lot more time to crack my own code here, and I have learned so much with other videos and doing some book readings, and so we can move on here and extend again, do a last enhancement of our assumption, so to say. If that here is an S, and if you remember the CDF and the flag format, which is always SecurityValley and then in those curly braces here, we can try to extend the brute force script to maybe guess which character was used on which position to reach the final valid license. Yeah? But at this point, I would say we have kind of figured out the logic of the program, and I think it's time for a break here. And I would say in the last part, we're gonna write together the brute force script, maybe with Python, which will do the final crack for the challenge. So therefore, I would say thanks for watching and see you in the last part.